Good afternoon, everyone. I think we're going to go ahead and get started. We've got a minute after 12 here. Just so everybody's aware, the session is being recorded and will be available after we're done here. I believe the slide deck will also be available. So thanks for coming. My name is Justin Patton. I am a solutions architect here at Netrix. I've been doing application development for over 10 years now, specifically in the cloud and Azure space for about the past 5. So our topic we're going to go through today is developing new capabilities for your district faster, the cloud app development. This is intended kind of as a level 100, maybe dabble a little bit in 200 level information for what you can do with app dev within Azure. Some of the things we're going to go through today, why we should use the cloud to build apps instead of kind of the on-premises way we've done it to this point. We're going to go through several different scenarios for moving some of your existing applications from on-prem up into Azure, but then we're also going to go through maybe developing new features or doing a new greenfield development directly on the platform. So we'll cross some of that in microservices and service fabric. We'll talk briefly about some of the data storage options that are available in Azure, so SQL Server or document databases, things of that nature. And then we'll wrap up doing a brief discussion on DevOps and how you can kind of optimize the code and the flow of the deployment once you're up in Azure. Concurrent requests, things like that. We can define rules to just have the platform automatically handle that for you. So that's a big thing we like to see as well. The predictable bursting piece, maybe you have a task you always run at the end of the month. So you could define a rule that on the last day of the month you want to double your compute size, and then after the day is over, you scale it back down. So it just gives us a lot of flexibility on scaling up and scaling down, and then also scaling out to a bigger machine or scaling back in. And we can do all that either manually with a couple mouse clicks, or we can also define rules to handle all that for us so we don't have to do it. And then some of the economics that are closely tied into the scaling story is the cost savings that you can get by defining those rules or turning things on and off that maybe you wouldn't get with some of an on-prem type infrastructure. So we kind of try to establish a baseline, what is the average required resources we're going to need, and then we kind of define rules around that. So that by itself, if you think about maybe an environment you had been running in a cloud or even on-prem previously, if it was running 24/7, but it didn't necessarily have to be, you can definitely have some cost savings around just turning those resources on and off. And it's not just the resource cost as far as what it looks like on the bill, it's also the time and effort of yourself or your coworkers to actually have to perform some of those tasks. And we also talk about, with app dev, maybe you do have hard requirements on running your production environment on-premise, which is fine. But then you could also look at leveraging a dev test environment in the cloud, where maybe the IT staff will let you have a little more self-control as far as turning on new machines and deploying things versus on-premise where maybe you don't have that luxury. So those are all things to consider. So let's kind of look at a holistic view of a cloud and IT strategy. Traditionally, before virtualization became really big, where you just had your data center, whether it was one or maybe did a colo or something like that, but you had the one data center. And you always worried about, we need new servers, so then we need new racks and new cabling. So virtualization came around and tried to alleviate some of those concerns. But then we also had problems of virtual machine sprawl, where we created a machine 6 months ago, 12 months ago, and it's still out there running, but we don't know if that person still needs it. So our virtual infrastructure started to get filled up. Once that happened, everybody started looking kind of at public cloud platforms or co-location, if you will. But there's always the concern around security and data flow and some things like that. And it's also another piece that has to be monitored and maintained, maybe external to normal IT staff. So then we started adding in, we don't want to maintain virtual machines. We don't want to maintain our own copies of Exchange or Dynamics or any of that stuff. So then we started buying and using software as a service. So as an IT organization, you tend to have a lot of things you have to monitor. Now it's not just your physical on-prem servers. It's also your virtual on-prem and public cloud and all these things to kind of keep track of. So what we're going to talk about is trying to alleviate some of that from an application development standpoint. How can we simplify where things live, how they're deployed, and kind of the work that is required not just on the development team, but also on the ops teams as well. So from a holistic Microsoft view, these are some of the things that are available to you. Our focus for today is primarily on the Visual Studio family, Azure App Service. We will briefly touch on some of the Azure Stack capabilities and where that may fit in, but just wanted to give kind of a real brief high-level overview of all the options of things you can use from Microsoft within this space. So let's go through and let's actually talk about some of the applications you have today, what we could do with those, maybe what's an easy entry point, and then kind of how we can do incremental steps on top of that as you get more comfortable with Azure. So the first one that's available, just right out of the gate, if you're just wanting to dip your toes in the water a little bit with Azure, is just moving the existing applications that you're running on premises up into Azure in the infrastructure side of the things. So take an existing machine that you have today, whether it has SQL Server on it or IIS, or maybe you're running Apache or something like that, and just move it directly into infrastructure as a service within Azure. Don't use any of the platform capabilities. You're just moving, essentially be the same as moving to a different server within your data center. There are various services in Azure to simplify how some of that would work. I know often with legacy applications, you may be using file shares. Azure offers the Azure File Service, which is essentially just an SMB share that looks the same as if it was on-premise. So for most applications, it literally is a lift and shift. You're just moving your executables or reinstalling some applications up on a virtual machine in Azure and then moving some databases. So this is a great opportunity, especially for some of the dev test scenarios, to move those up there and just see, does my application work? How hard is it to get it running up there? Kind of the phase 2 of this approach would be actually using some of the platform services that are available within Azure. So this one specifically we're talking about is web apps. So if I've developed a .NET application that normally runs inside of IIS. In most cases, it's as simple as just deploying directly to Azure App Service. If you're running inside of Visual Studio, you can just right-click on the solution and tell it to publish and choose Azure App Services, and you're on your way. Obviously, if you have a SQL database behind that it needs to talk to, you would need to publish that up to Azure. And they do offer SQL Azure, which is SQL Platform as a Service, which we will talk about later. But app services also have the ability to create what's called a hybrid connection. So for some reason you still wanted to leave a database on-premise, you can install this agent that allows the Azure App Service to reach back through onto your internal network and still read data out of it. So they do offer incremental steps. Obviously, we're aware that not everybody just uses .NET or runs inside of IIS. So there are non-IIS options, such as Node.js or PHP, Python. Any of those also fall into this realm of being able to be deployed to Platform as a Service. The nice thing with Platform as a Service versus the infrastructure side is that it removes any patching or Windows maintenance or any of that kind of stuff from you or your operations team. So in the previous scenario, we were doing lift and shift. You would still have to patch that Windows machine and create user accounts on there, maybe even join it to your domain if you needed to do that. In the Platform as a Service, you're only responsible for your application code. So you don't have to worry about any of the Windows patching, securing any of that, doing any load balancing. That's all handled by Platform as a Service. One of the nice things with this as well is you can have a single Azure App Service that is able to host numerous applications inside of it. So from a dev test scenario, and we'll talk more about DevOps a little bit later, but the flow that's shown here is kind of along the lines of continuous integration. So you have some developers that check in code. They call it here Visual Studio Team Services, but it can also be tied to a GitHub repository, or you can hook it up through Jenkins build server, however you'd want to do it. And then we can have, as part of that build, we can have deployment done to Azure automatically. Azure does offer something called development slots or staging slots, which is what's being illustrated here. So you can deploy to your dev test environment. Once that's been reviewed and blessed by whoever needs to do that, you can press a single button, swap it over to the staging environment for if somebody wanted to do some extra testing or a different group had to approve it there. And then you can also, from staging, click the button again and switch it over to the production slot. We often use the slots just to do staging and production. And what that allows you to do is essentially migrate new code without any downtime apparent to the end user. Behind the scenes, it's essentially just changing some DNS entries around. So that's how they're able to achieve kind of the swap without the users experiencing any downtime. So from a high level, as far as what you can do with existing applications, those are the nice and easy entry points to get in. What I'd like to talk about a little bit next is more along the lines of if you have maybe a new application you're going to write, or if you have an existing application that you really want to try to take advantage of the platform with, maybe some things you would try to do and things you would look at. So we'll talk briefly here about microservices and also how Azure Service Fabric fits in with the microservice model. So why should we use the microservices approach? The idea behind microservices versus the traditional monolithic application is that you're able to develop each individual service and change it without impacting the other services in the environment. And we have some good kind of illustrations of that in the slides as we come up here. But it's the ability to make a change to a certain service that has business rules inside of it, and you can deploy just that one service, and all you have to test is just that one service. There's no longer concerns about, my developer said they only touch this part of the code, but we really should test these other things because they may have touched that as well. there's true separation of concerns within microservices. So you can easily version them independently and test and deploy them independently as well. You're also able to build and operate them at scale. So you could have maybe 10, 12 services that are running, but maybe 2 of those are really resource intensive. So you're able to scale just those 2 services without also scaling everything else. So what does this look like as far as trying to compare the monolith versus the microservice? And by no means am I saying that everything going forward should always be written as a microservice. There are definitely places where monolithics may still make sense. And microservice also does not imply the size of the code base or what it's capable of. It's more trying to identify separation of concerns, business rules, things that are volatile that may need to change a lot usually get pulled out. You can definitely have a microservice that is 100 lines of code, but you could also have one that's 1,000 or more. The size of the code base definitely does not force it one way or the other. So like I talked about before, if you have a monolithic application, in this case, maybe there's 3 in-memory services that are running, but let's say that the red service is the one that's really resource intensive. If you wanted to scale that application up, you really don't have the ability to just increase the number of red services that are running. It increases everything else that's a part of it. If you look at the microservice approach, now we have the ability to say, I want at least 3 red services running, but if there's only 1 or 2 yellow services, I'm fine with that. Or if you need to increase them, you can easily do that. You can have different size of underlying virtual machine for different services. So even though they're all written in the same code base, they're all deployed from the same code base, you can define how big the machine should be they run on, how many copies of it, and how all that looks. So you have a lot more granular control over everything in the microservices world. It does introduce some complexities. In the traditional monolithic model, in most cases we just had a single data repository that lived on the back end. You may have various different repositories at a code level, but in the end they all kind of boil down to a single SQL database. In the microservice approach and the ability to version the services independently, you also may need to make schema changes independently. So often with microservices, you will have a different data store per microservice. This is one of those architecture patterns that you can either take all the way there and truly do a new database for each microservice, or I've done systems that had clients that will do a single database still, but you essentially assign ownership of tables to services. In that case, it still works and kind of allows you to do what a normal microservice pattern would want you to do. You just have to be really careful about not trying to do joins between tables and things that may happen to be available now just because you're all in a single database. If you are using multiple databases, one per service, it also lets you maybe have a SQL database for one service, but maybe you want to use a document database or MongoDB for another service. So it allows you to kind of pick and choose what data formats you want to use and where you want to store it. It does introduce a reporting complexity that if the data is stored in multiple locations, that you may have to have a different microservice that is essentially responsible to aggregate all the information from the different services. So just things to consider as you're going through. So how does Service Fabric fit into all this? Because obviously with microservices, and you start to think of things like containers, which always brings up Docker, which is another popular container service that's out right now. Service Fabric essentially sits on top of a microservice foundation, but it adds a bunch of features on top of it. And Service Fabric is something that Microsoft uses internally. If you use SQL Platform as a Service, that is actually built on top of Service Fabric. So this is something that they have developed over time, and use on a daily basis. So some of the things that come along with Service Fabric, things like rolling upgrades. So if I push a new application package to one of my services, it'll roll it through each of the different replicas that are out there and won't have any downtime. If it detects any issues with that upgrade, and this kind of falls into the self-healing and health monitoring portion, if I publish a new upgrade and the service doesn't come up cleanly, it will actually roll back the change automatically to a previous version without you having to do anything. There's a concept of stateful services where you can actually store information within Service Fabric and not have to send it out to a SQL server or a document database or blob storage. And you're actually able to communicate directly between services within Service Fabric. So you don't have to write web API front ends to all your different services. You can actually just talk through a proxy to other services that run inside of Service Fabric. Service Fabric is able to be run in Azure, obviously, but we talked briefly about Azure Stack before. And Azure Stack is, in essence, a private version of Azure that you can install in your old data center, and Service Fabric is one of the features of Azure Stack at this point in time. So Service Fabric is something that interests you, but you're not quite sure if you want to run stuff out in Azure yet, but the self-healing and the stateful services and some of this is interesting to you, you can install it on-premise and run it from there. And then should you in the future want to go up to Azure, it should just be as easy as deploying to an Azure Service Fabric cluster instead of your own local one. So what does it look like from a traditional cloud services Azure setup versus Service Fabric? This is similar to the graphic I showed before. In the traditional way with web and worker roles and also with Azure App Services, you in essence, if you scale up, you end up moving all of those applications, all that functionality to the other machine. You don't have the ability to really split up and scale the pieces independently. When you move over to a Service Fabric type model, you can better utilize the servers, add more of a certain service type. You also have the health monitoring built in. Deployments and upgrades are a little bit easier to use. So there's benefits to both sides. There are merits to using either or. Like I said, this isn't a magic bullet that we do everything with microservices and Service Fabric, and that's how it should always be. Microsoft does have articles about maybe when a monolithic still makes sense. This is just trying to introduce a newer way of doing the architecture. So we have all of our services in Azure. But now we need to maybe take a look at how our data is stored. We're not in our traditional monolith anymore, maybe. So we want to maybe put some data in a document database or put some data in blob storage. So what does that look like from a Azure side of things where our data can live? So several options, obviously, within the Azure world, depending on what type of features you're looking for. So on the far left-hand side of this graphic, essentially would be what you're used to maybe on premise today. So SQL Server, just running in a virtual machine. Microsoft offers a gallery with different SQL Server images in it that have been created kind of with the best practices in mind. So it takes some of the setup away from you. If you maybe have a DBA who is very particular about how they want a SQL Server installed and running, you can definitely just turn on a virtual machine and install SQL yourself. But in the past, I've traditionally used the galleries that are there and available. So with that, obviously, you get the fully featured SQL that you're used to today, all the normal transactional, ACID type processing, and rich querying abilities. If you move up one column to the right and we go to SQL Platform as a Service, we get some of the same functionality as SQL Server in the VM, but we also bring along that now it's managed as a service. Gone are the days of really having to worry about backups based on the tier you choose within SQL Azure. You could have a point-in-time backup to anywhere within the last 31 days if you wanted to, where you literally just click a button and it'll restore the database to that point in time. You have the ability to scale it, so they do things based on DTUs, which is essentially a throughput metric. Maybe your system's being used more than you thought it was going to be. Go into Azure, click a button, and now you have a higher performing database. One column over from that, we move into the document DB area. So it's a JSON type database. If you're familiar with MongoDB, it's also similar to that. Document DB also offers MongoDB drivers. So if you've written an application or if you're more familiar with Mongo, you are able to talk to document DB in the same way you've talked to Mongo in the past. So once you get into the document databases, obviously we're into kind of the schema-free world. It's also accessible through an HTTP interface if you would need to get at data that way. But it still leaves us with the rich querying ability and the transactional processing that we're used to from the SQL database side of things. Some of the less expensive alternatives within Azure are table storage and blob storage. Tables essentially end up being almost a key value store, but not quite as simple as that. You are given two keys to work with, a primary key and a secondary key, but you don't have the same rich querying ability that you have with document DB. So most time tables are still treated as JSON data stores. They just aren't as queryable as maybe document DB would. Blobs primarily are going to be used for pictures, videos, maybe some flat files if you need to store. I mentioned Azure Files before. That's essentially built on top of blob storage. When you create a virtual machine, the VHD, the hard drive for that virtual machine, is stored within blob storage. So maybe your content that would need to be delivered could live in blob storage. So trying to use the power of SQL Server within Azure, you are given a lot of options. You have your own virtual machine within Azure. You have one from the gallery that you can start up. You have the SQL Platform as a Service, but you still can use your own on-premise physical and virtual SQL Server if you wanted to, whether that's through a hybrid connection that we're able to reach back across. If you set up something like a site-to-site VPN or an express route that you wanted to reach back, if you have some restrictions around where your data can actually live, it has to be in your data center, but the application can use it from Azure. Those are all options that we can go through and use as you're developing in Azure. So I briefly mentioned before about the SQL images being available in the gallery. That's not just a Microsoft thing. That's also Oracle, MySQL, that have been certified by the various vendors to be able to be used in Azure. So if there are still some things that you need the full-blown SQL for, that is available. I've run into some clients that have code that is written that is doing certain things with queries that wasn't supported yet in SQL Platform, which does still happen from time to time. So you still have the option of running SQL as just standalone on a virtual machine. One tier, if you will, kind of above the standard data access, just standard single database. You may want to start playing around with things like Power BI, which become even more powerful when you throw in a SQL data warehouse, maybe with some Hadoop type technology on top of it. That is definitely all available to you through that. Power BI is not just a desktop tool anymore. Microsoft also offers Power BI embedded, which allows you to actually put Power BI inside of your own custom application. It doesn't force your users to go to a different tool for some of that rich reporting capability. So you can actually develop the reports in the Power BI desktop client and then deploy it to be run inside of your application. So that's kind of a, what can we do once we're in Azure high-level overview. I also wanted to briefly go through today from the deployment and operations side of things, or DevOps as it's called now. What does that look like in Azure? What kind of benefits can your organization gain from that type of scenario? So DevOps is one of those things that doesn't have a clear picture. You can talk to 5 different people and get 5 different answers as far as what could it be? So is it a role in your company? Is it automation? Is it something that's just for developers? What does it actually look like? What is the DevOps story? So like this says, it is an emerging trend. At the end of the day, it's about trying to increase value. So I know the slide says for customers, but it's not just for customers at the end result who are actually consuming the application. It's for developers and stakeholders, project managers, to really increase efficiency and value throughout the whole development process. So what are some of the conversations around DevOps? There's the people part of this, obviously. So how can we collaborate more? How can we share goals amongst the team and work towards a more streamlined process? And within that process, how do we increase the efficiency? How do we not just have a good process in place, but we also need to provide feedback as the process is being executed at each step along the way? So if we want to include more feedback, how do we do that? We need to look at better tooling, which can give us better collaboration, give us better productivity. And the DevOps marketplace is definitely something that is exploding from a tooling standpoint. So we'll just talk high level about some of the tools that are available, but these definitely aren't the only ones and may not be the best ones for you depending on what your situation may be. So I'm not going to read each and every bullet point that's on here. Obviously the idea is that we're trying to get value better for everybody. We're trying to align the team and all those involved in the process to go along with this single thread of execution. It's learning from the process. Usually we talked about learning being just, when customers give us feedback, when it's finally handed to them, what are the bugs, what are the pain points. But again, it's not just about the end customer, it's also about all of the people that are interacting with the flow until it gets to the customer. It's looking at your technical debt that you may have. Maybe part of your DevOps flow is analyzing unit test coverage and looking at load testing metrics and things that you may have not looked at before because you didn't have the manpower to do it. And now a lot of it we can automate with DevOps. And then the last circle on here is an important piece to look at as well, that kind of viewing infrastructure as a flexible resource. That it isn't just when I'm doing development environment, now I need to always have this machine running 24/7, 365. You can easily, as part of a DevOps flow, spin up an environment, deploy to it, and then when that release or that environment is done, you could have it destroyed as a part of it. So it doesn't have to be as rigid as you need to stand up 5 new servers and it's going to take 2 weeks to get it done. The idea is to be as agile with this as possible. So again, this isn't just about the delivery, just about the customer. It's also about monitoring. So once we're deployed, what can we do to make sure the application is running, that it's healthy, that people aren't having any issues with it? And it's also about learning about the application. Maybe we put a new feature in that the development team thought was going to be heavily used, but then we have some metrics put in place that, guess what, somebody's clicked it once in the last 3 weeks and it really isn't. So it's about trying to just gather more information and deliver a product faster to the end users. So what does the DevOps cycle look like? So starting off with the developers, we're going to do commit out to a repository. Now you can have the next step going to build defined in multiple ways. Maybe you have an application that there's a lot of commits on a daily basis, and you really only want a build to run at midnight and just deploy whatever's committed to that point. That's one option. You also have the ability to turn on continuous integration. So at check-in, it automatically turns on a build. Part of the build process can also include steps 4 and 5. So maybe you're running unit tests that are just part of the solution. Maybe you're running automated user interface testing as a part of it. If those pass, and maybe it's with the development environment, you want it to automatically deploy that out to Azure. Maybe if it's a production environment, you want it to create a release, which we'll talk about release management here in a couple slides, that just basically gets it ready and then allows somebody to approve it to be deployed. And then kind of to close the loop on the circle, then we monitor that application and improve. So there's tools like Application Insights that Microsoft provides that allows us with very minimal code track a lot of metrics around page impressions and CPU performance, dependency tracking. Maybe you have an application that talks to a SQL server. We just talked about using SQL in various ways. With a couple lines of code, it'll actually monitor how long each of those calls into SQL Server took. And then if you have users calling and complaining about a page being slow, you can pull up a dependency graph, and you can see for this page, for this call, how long did each dependency Azure Event Hubs. So if you want to know any more information about that, definitely feel free to reach out, and we can try to get in contact and talk more about those. If there's a certain topic that I talked about that I may have breezed over, or you wanted more detail on, or something that you thought I'd cover that I didn't, again, reach out and we can set something up to go through these things in greater detail. As far as upcoming sessions within the series, we have a slide up now showing those. Next one being December 2nd, about leveraging hybrid tooling and moving to the cloud at your own pace. Having not been in these in previous weeks, I don't know if we allow Q&A at the end of this. I don't know if we can have, if Becky's here, she can say if we usually allow that. I'm definitely open for it. Okay.
Absolutely, Justin. So this is Simon Ibbott here.
Simon's here. Okay.
Yeah, guys, if you've got any Q&A, please feel free to pop it into the IM window and we will moderate. If not, I've just popped my email address in there, so please come back to me or Justin, and we can set up one-to-ones or moderate. So slide deck. I'll pop in a link now, Mike. There's a slide. There's a website. It's Azure123 on demand. I'm going to stick that in the window now, and basically that covers all of the webinars that we've done over the last 3 weeks. Any other questions? Okay, well, thank you very much for joining. As Justin said, we've got 3 other sessions that are Azure-based K through 12 scenarios over the next 3 weeks. Again, the more that we can kind of educate you guys and kind of demystify Azure, the better. There is also some business investment fundings as well. So again, we can apply for up to $4,500 on your behalf to help get a partner in to help you run through these scenarios over a 4-day webinar, a 4-day event. But again, my details are there. If you've got any other questions, please come back to us. This slide deck and recording will be available in the next couple of hours on that site. Have a great weekend and a great Thanksgiving.
Thanks, everybody.